So today's presentation is going to be on a partial decoupling, how we used React and Drupal and Apache Solr to build a really responsive search interface for one of our clients. It's a case study. I'll do a little bit of a demo, but then also talk about the architecture and some of the decisions that we made. So hopefully that will help anyone else who's doing things in the future. Here today, designed for Drupal, Boston 2018. Wanted to get that in for the recording. First off, I just want to tell you a little bit about me. My name's Dan Murphy. I'm a web developer at Solr Labs. We're a small Drupal shop centered in Durham, but we're a distributed team. About half of us are in Durham, but I live and work in Boston. I live in Rosendale. I spent my whole time life in and around the city. Went to school at Tufts. So outside of Drupal, I rock climb a lot. You might see me at the rock gyms if you go there, or you might see me running around the Arboretum or the Jamaica Pond. So that's a little bit about me. I also just wanted to share a slide about our team for two particular reasons. One, this project was a really good opportunity for us to collaborate and work together on the same project. We all are often separated working on different client projects. This one, 4 of us worked together on it and we worked in parallel. So the architecture really allowed us to leverage our individual experience. And then also, just to connect to the audience a little bit, Chris, our founder, used to work for Isovera, which is a Boston Drupal shop. So if anyone works there or know anyone that works there, my colleague Ro, her husband works at Pega Systems, who actually gave a great talk earlier today on web components. Her husband's Ramy Denton. So he works for a local Boston shop as well. So ties to Boston, not all distributed. All right, so when I was putting together these slides, I was trying to guess what the audience would be interested in. And I assume everyone here works on Drupal websites, and they're thinking of ways that they can improve the experience for their end users. So that's the primary point of view for this presentation. I'm hoping to inspire you with our case study, but also share the architecture. So if you were interested in doing this, you could reproduce it on your own, or reproduce something similar in another progressively decoupled way. So not to bury the lead, the case study is on this deliverable product that we delivered for our client, eOmega. If you have your laptops up, I will do a demo, but you can access it at that URL. It's a React app, and it's a search interface for them. A little bit about the client, because I think that guided a lot of the decisions that we made. They're a nonprofit retreat center. Primary location is in Rhinebeck, New York, upstate New York. They also have satellite campuses in New York City, and they do some in Costa Rica. They've been around for a while. Their primary business model was they offered on-campus workshops. People used to call on the phone to book, but they've grown into the digital space over the years. Now people book online. They also offer online workshops that people can attend and view online, and they supplement their site with articles related to some of the workshops they do. They try to fund themselves through memberships, so some of the content's only accessible to members. And what they found is that search is the primary way users engage with their site. They have so much different content, and people want to engage in a lot of different ways, that they really come to the site and use search to find their content, and they found that their search that they were using wasn't serving that need. So here's just an example of their prior search. I cut and paste 2 together so you can see the top and the bottom of the screen. They already had Solr in place, so they're already using Solr as a backend, which simplified this project a little bit. And they were using a Drupal view to render the results. So it's a simple Drupal view. You click on next on the bottom, and loads another Drupal page. So that was the prior search. Now I want to do a live demo. Fingers crossed this goes well, of what the search is like now. And it's something I'm very proud of. I think it came out pretty well, and the client was very happy with it. So I'll refresh the page at the end. It's very, very fast at home. I was having a little bit of slowness initially when I loaded it. So I'm going to walk through a couple different aspects of this. The first aspect is how when you click on any of the content types, you'll see that the content updates basically immediately. So if you're interested in workshop events, you click that, and the results is very, very responsive. You can apply multiple filters to get different combinations. Clear all will reset it. Workshop dates. Let's say we're interested in workshops only between the start of the month and the end of the month, and that updates, and it also updates this component to indicate that it's workshops and events that are being searched. Clear all again, just to reset it. Maybe you're interested in New York only campuses, so again, a filter, and this is sort of tied that it only shows workshops in New York. And again, pretty rapid. And then topics, which I'm going to talk a little bit more, but these are taxonomy terms in Drupal, and these are updated. If they're updated in Drupal, it'll propagate to the React app. So if you're interested in things that tag body, mind, and spirit, or health and healing, and as you can see, the search results update on the fly, and that's really one of the primary benefits. Also, unlike having to hit the next page and wait for the page to reload again, if you don't find enough content here, show more, and it loads basically instantaneously. It is responsive as well, so it'll go down to two columns, and then on mobile, the filters will be something that you can expand on. One of the challenges in the architecture that I'm going to talk about more, because I want to start high level and then get into the details, is with the search autocomplete. That was really important to them. So if you start typing yoga, it'll autocomplete for you. Yoga is a pretty straightforward one. We search on that. I'm going to clear everything else here because I'm not interested. And you can see some of the results for yoga. But a lot of their instructors have difficult to spell names. So autocomplete was, or at least the end users had difficult time spelling them. So that's another reason autocomplete was important to them. So for example, Desai here. If a user wasn't sure how to spell it, they could start typing, and then they'd get autocomplete that would help them hone in on what they're looking for. So again, helping the user find what they're looking for. And another aspect that I'm going to talk about a little bit later in terms of the analytics components of things, if you click on any of these links, we're actually tracking what people click on so that we have a better sense of what people are searching on, and that's guided some changes since then. And then also, if you click on these, there's query parameters appended so that we can also track through the pipeline so that you can see which tend to have the most conversions. So it helps make, when we implemented this search, it was really important to them if they knew how things were doing, if it was better, if they were getting certain conversions from certain things. So that's another aspect of the deliverable, which I can talk about as we go now. So live demo actually went well. I was a little skeptical. The ambiguous client statement, one of the stakeholders said, 5 seconds in and I can already tell it's 1,000 times better. So it was a real win in terms of they were really happy, and we were really excited to just use these technologies and work together on it. I put together a couple slides here because I wasn't sure about the audience background. With decoupled Drupal and progressively decoupled Drupal, there's a lot of lingo, jargon around those. So I just want to spend a couple minutes making sure we're all clear and on the same page. Decoupled Drupal, headless Drupal, it's a very popular term these days. Generally speaking, it means Drupal is your data provider. And it provides an endpoint that the consumers can access. So you could have Alexa and Amazon Echo pulling data or getting data from Drupal. You could have a smartphone app. You could have a React app. You could have another Drupal website communicating with the Drupal endpoint, or a TV, or your browser. So that's decoupled Drupal. Progressively decoupled Drupal is slightly different, and the idea behind that is Drupal still does most of the heavy lifting. And then you use some of the front-end frameworks like React or potentially Angular, and you use those to render discrete components of your website. And what I'm presenting on, I would describe as progressively decoupled because it's only the search, and React is only being used to render that discrete component of the site. And the benefits of progressively decoupled are that Drupal provides so much out of the box, and also there's this incredible contrib module ecosystem that's available, which we leveraged in this deliverable. So a lot of this crowd is very familiar with the Drupal search ecosystem. There was a great talk earlier today by Jason on Apache Solr. But just so we're all on the same page, Drupal ships with core search. It's somewhat limited. It has somewhat performance issues, especially on highly trafficked website. There's the search API module, which is really a framework module, which allows you to index any type of entity and then integrate with various types of search engine backends. In this case, we're using Solr Search, so we need another contributed module, Search API Solr Search, which provides that integration between the Search API and Solr. Two other modules that we ended up using for this particular app were Search API Pages, and I'll explain why we needed that, and the Search API Autocomplete, which I demoed, but I'll also explain how we use that a little bit. I X'd out this Apache Solr Search because in Drupal 7, that was a module that was somewhat popular. Search API seemed to win the battle. But if you just Google search Apache Solr Search Drupal, you might see that one. We didn't use that one at all. This reminds me of something I actually skipped over earlier when I was talking about this client. I wanted to point out and make it clear this client is still actually on Drupal 7. And upgrading to Drupal 8 is important to them. And that's in their long-term plan. But in the meantime, they really wanted to improve their search. So a progressively decoupled search was actually appealing to them because they wanted, this is something, the React app, that should port to Drupal pretty seamlessly. Nothing is completely seamless, but this would be much easier to port rather than doing a whole bunch of Drupal 7 upgrades or updates. So just to talk about how Solr integrates with Drupal first, just to make, again, sure everyone's on the same page. Drupal has the Apache, the Search API and the Apache Solr search, the Search API Apache Solr integration. You configure what you want to index. On cron runs, it pushes to Apache Solr, or when content's updated, deleted, you configure it to push to Apache Solr. Apache Solr builds the index. When Drupal wants search results, it pings Apache Solr and it gets the results back. So that's how Drupal communicates with Apache Solr. The end user, when they go to a typical Drupal search page, they send the request to Drupal. Drupal sends it to Solr, gets it back, and then Drupal renders an HTML page and delivers that to the end user. And that's what they had here. Drupal was rendering, that's a view, Drupal rendered the page with the view and returned it to the end user. And as I said, if you click next, that's another request to Drupal. Drupal bootstraps, renders the page, returns it to the end user. Our progressively decoupled architecture, I have a bunch of diagrams here now, in which I can go over this a little bit. This is a pretty complicated slide, but I wanted to capture how our app works. And in particular, I highlighted some of the arrows in red so that I could not forget to talk to those points. You see now, Drupal's pushing to Solr, but Solr is not sending any of the data back to Drupal. Drupal's still telling Solr what to index. So content's updated, deleted, cron runs, Drupal pushes that to Solr. The arrow from Drupal to the browser is in red because now, instead of returning a fully rendered page, including all the search results, Drupal is sending a very basic page and JavaScript, the React app.js, which is why I have that the React logo up in there. I'm going to jump forward one slide to show you what Drupal is actually sending back. Very simply, this is the markup in the template file that's being, this isn't everything, but this is the markup that's being sent back to Drupal. As you can see here, this actually does require JavaScript to work. So if you don't have JavaScript, it's going to tell you, sorry, you must enable JavaScript to use the search engine. That was a conscious decision. We discussed how this would work if an end user didn't have JavaScript, and the client accepted the trade-off that the search does not work without JavaScript enabled. And then it has this div with the ID JS Solr search, which the app.js uses to build out the entire page. So I'm going to go back a slide. So you notice when I was doing the demo that it was really fast. And the reason it's really fast is because when the user interacts with the search page, React is sending a request to this proxy.php script that we have on the server. So that it's in the repo, in the Drupal repo. You see the dotted line. That's within the project root. There's a proxy.php and that's accessible for the React app. And that is a really lightweight PHP script that does just some minor security just to make sure people can't use that to query the entire Solr index. And sorry, I might have misspoke there, but it just does some security validation. And then it sends a request to Solr, sends back the results to the proxy.php, and then that returns it to React. So this is really quick because it doesn't bootstrap Drupal. As I said, it's a really lightweight script and a pretty small script, and that's how React is getting that new data. So whenever you hit more, that's where it's loading more when you apply the filters. Later on in this presentation, I'm going to go over a little bit about the React architecture and how that's working. Now, I talked about autocomplete before, and that actually added a slightly another layer of complexity to this project. So let me jump up here. So actually, proxy.php does communicate with Drupal, but only when you start typing into the autocomplete box. So if you're just using those filters, it bypasses Drupal. Drupal never bootstraps. If you start typing into the text area, proxy.php actually uses Drupal to figure out what terms to show. And I want to talk a little bit more about that. And as you see, I actually added the red arrow because Solr does push back to Drupal on that, or does return information to Drupal in that situation. So this decision was made for a couple of reasons. One, this is a real project with a real budget. One of the first things we looked into was using Solr Suggester. So Solr does have ways to do autocomplete. We started down that route to begin, and we're finding that really difficult to implement, and we're having a lot of challenges. We tested out another method which uses the Search API autocomplete module and the Search Pages module to create basically an endpoint in Drupal. The Search Pages creates the endpoint along with the Search autocomplete so that proxy.php can send a request to the page with the autocomplete as part of the query parameter. And then Drupal Search autocomplete module returns the results. And that was a way for us to, in this rapid development, to leverage the autocomplete module and in a way that was still fairly performant. So in the demo, you might have noticed that it still was pretty quick with the autocomplete. So that was the way we worked around one of the problems with autocomplete in this situation. Just to talk about that endpoint, we did restrict access for users. So I believe it was in Hookinit that end users can't access that page. And as I said, this is a fairly complicated slide. I'm very happy to return to this one towards the end of the presentation. I'll try to leave enough time, a fair amount of time, so that we can go over any questions with the actual implementation here. Now onto the React architecture. I am mostly a back-end developer, system architect, system admin, but I do front end from time to time. I get to dabble, and I actually got to write some components for this, which was exciting for me because I like to do new and exciting things. But my colleague was the one who put together, who was primarily in charge of putting this together. So if I misspeak about React at all, I apologize. But for those a little less familiar with React, the way it works is you build components. It's essentially component-based, and you start with the large app component, and then you break that into segments of smaller components, and then components that exist within that. So I circled, we put a big box around the whole thing. That's our app component. That has two subcomponents, search filters and search results. And within the search filters, we have a whole bunch of components. The clear all component, the search autocomplete, the content types, the workshop dates, location. And then within the search results, we have the tile grid. Within the tile grid, we have tiles. And then at the bottom, we have show more, which is another component. So this architecture has a couple benefits. One of the reasons React is really reactive is because the way states and properties flow in in React. And that means it makes it really easy. So if you change something in the content types, it will flow up to the app and then flow down to your search results. So the search results automatically populate. If you click the clear all component, it will, the state will rise up to the app container, and then the properties will flow down, and that will reset all of your other filters. So, and then your search results will also reset. So that's why you change one thing, and the other things react almost instantly. And that's, that was really exciting. I haven't done as much React development, but when I started using it, I was like, wow, this is really, really nice. And also, the way we did this was each component is its own file, so that developers were able to work on different components in parallel. So I was actually working on the content types filter component while another developer was working on a different component. So it made it really modular, and it made it really easy for us to work in parallel. And I mentioned earlier this was a project that allowed several of our team to work on collaboratively. It's because my colleagues set this up in a really good way that we could work on different components at the same time, but also part of the that proxy.php was being developed in tandem. So there was a lot of things going on in parallel. We were able to do a really short turnaround in this case. A little bit more about the app data flow. I was talking about it a little bit before, but again, states lifted up. So if the clear all is clicked, that rises up to the app. The app stores the state, and then it flows down to each of the components. So as you can see, the purple arrows which go up are all the state flow, and the green arrows going down are the properties flow. So, and React just handles that for as I said. The changes go up, and they propagate down to each one of the child components. The key to this app, which is one of my few text-heavy slides, because I didn't want to misspeak on this one, is the React Solr connector component. And this is a component that was already developed and is available as a node package that we leveraged. We actually leveraged a fork of it, and my colleague contributed to that fork. And this is a React component which provides access to a Solr server. By including this component, I'll talk a little bit about how our development workflow too in a minute. But we included this in our packages.json. Run npm install, pulls in this component, and then you can use it in your development. So we're able to pull this component in, and that's really the top layer. The app.js uses that one, and this uses the Solr JSON API. That's how JSON, the Solr sends back JSON, which is consumed by the React app. And again, you pass the Solr connector component the search parameters as properties. And then the component updates and pings Solr and handles that. And in case you just want to Google later, React Solr connector fork is the one that we use for this project. All right, challenges, considerations, and tips. I'm going to walk through a couple things here. Okay, so accessibility. So when developing these React components, they're written in JSX. We need to just be more mindful to write semantic HTML that was accessible. Drupal does a lot out of the box for you in terms of accessibility. So when you're writing your own components and you're handwriting the HTML, you need to be much more cognizant and aware. And that's something that we want to be mindful of when we do that. And it just is something slightly more challenging. So that's one thing when you talk about decoupling Drupal. One thing that Drupal does really well is accessibility, especially Drupal 8. And when you stop using Drupal to render the page, you need to start thinking about that with more consideration. Local development and workflow. So in this project, Apache Solr uses the term, well, if you're using Apache Solr, use the term server, which is sort of like an index. We ended up creating a new server on the production Solr instance, which indexed production data. It was not the index being used by the production website, but it was essentially compatible to the same as that, which all of our develops used during development. It used that index. We thought through this. Another option was to run Solr locally. Everyone could run Solr locally. We use Docker for local development. There's the Docker for Drupal stack comes with I believe, a container for running Solr. But this was a really fast turnaround. We thought through it. One of the challenges was that everyone would have to index the data, and then people would be working off potentially different indexes. So we talked it through with the client, and we decided the quickest method to get everyone up to speed and everyone using the same thing was to create another index on the production Solr, which local developers pinged when they were doing development. Another aspect of local workflow was when you're working with React, we used, so again, I may misspeak here because this is not my area of expertise, but we used Babel to write ES6 JavaScript, which transpiled that to ES5 browser compatible JavaScript. And essentially, we had NPM scripts that we could run to, first of all, NPM install would bring in all of our dependencies locally. It's sort of, if you're a Drupal developer, with Composer install. And we used, there was a script, an NPM script to basically watch so that you could, it's like Compass Watch. If you're changing your JavaScript files, it will rebuild the app.js, because what this is doing is that you're developing these components, and then it's building this one app.js file. So in local development, that's something that is really useful if somebody sets that up for the team, so that the team can just worry about doing the development of the component, and they can run npm some watch script, and that will automatically propagate, update the app.js file. I mentioned a little bit about autocomplete already. The other thing I wanted to talk about was adding that app.js to the page. I showed you the HTML for that page earlier. And we ended up doing a preprocessed HTML, and we add the JS there. We use the Drupal settings to pass in some of the information, so as the page loads. So that's where I was talking about the terms before. There you go. It loads pretty fast. The first iteration of this site, we didn't really pass any information to the app. The app was, once the app loaded, it then fetched the topics, and the teachers, and any of the other, like the content types or anything else. But now we use, when we do the Drupal add JS to the page, we pre-fill it, pre-populate it with the topics so that the page loads more responsibly. It doesn't have to do a bunch of requests to get that. So when you're adding the JS to the page, the app.js, which is essentially this whole page, which renders the whole page, we're passing in these taxonomy terms. So again, if somebody adds a taxonomy term via the admin UI, it propagates down to this app that way. Go back to present mode here. I talked a little bit about analytics, but yeah, we use Google Tag Manager, Data Layer, and Google Analytics to track clicks, and then ultimately use query parameters on the results that the user clicked on. That actually did drive some of the decision making. So teachers was above the topics before, and we found that people clicked on the topics 3 times more frequently than they clicked on the teachers. So we switched that around, and now topics is first. Hosting is a factor that if you're going to go this route, you need to think through and consider, because this client uses a hosting provider that they have a lot of flexibility on in terms of Apache Solr. But I know a lot of the managed hosting providers, Pantheon, Acquia Cloud, those two have more restrictive Apache Solr on the configuration for Apache Solr. So if you were going to think about this, if you're being hosted on a managed hosting provider like Pantheon or Acquia Cloud, I would first start with verifying that this approach would work for you, that you can communicate directly with Solr via your proxy PHP. You may not be able to do that. I think platform.sh, you wouldn't have a problem, but that is something that if you're going to undertake a big project like that, you need to consider that earlier on. And Pantheon was out front tonight, earlier today. Tomorrow you can ask them if that's possible. Some of the other best practices that I found while we were working on this was try to contain everything in its own module. We have one custom module where we have a bunch of the code that we wrote for this. Sort of like Composer, or if you're using Compass for your CSS. We version control, we don't commit the final, we don't commit the dependencies, essentially, that we pull in through NPM. We commit the packages.json. We use NPM install to pull those in locally, and we build the final JS, which we deploy, which is the compile JS, and we build that as sort of a build artifact that you deploy. So you don't necessarily have to have NPM installed on your production server if during your build process you're creating your final build artifact. I can talk a little bit more about that at the end, but if you're building sites in Drupal 8 with Composer, that's something you probably had to think through on how you're going to basically pull in your dependencies and then deploy. I'm probably forgetting some of the challenges and tips at this point, but yeah, I'll move forward. Going forward, so this project was, I think, an opportunity for us to really implement some decoupled Drupal. And it's really interesting where progressively decoupled Drupal is going. I know there's core initiatives to sort of build a React interface for watchdog messages, the logs. And that's going to be the admin interface, where it's React and it's really responsive user interface. And I think you can use this as an example as you go forward to think, okay, what components might I be able to build a React front end? And you could follow a similar model where you return a page and load that app.js. And I actually went pretty fast. I think I have a little bit more time, but that is the end of what I prepared. But I also want to open up to questions because this session at least has another 15 minutes, I think. Yes?
Okay, so you mentioned state within the application, and this is a fairly simple React application.
Yes.
With the state going up to to your app.js and then coming back down. Did you use a state management utility, or did you just propagate everything?
Yes, we did not use Redux, which I believe is a popular state management tool. This is talking a little bit
Redux
outside.
is fairly popular. There are a lot of like different flavors.
Yeah. Let me see here. Because that's actually, yeah, I think we did not use any of those. And I believe, I was looking at this earlier today. Yeah, let's see if I can do the fork here, because this actually had a little bit of an example of, yeah, okay, having a little trouble finding it right now. But yeah, we did not actually use this first one.
What you showed was very small architecturally.
Yes.
So like it might have been overkill to have a state
Yeah.
management system,
Mm-hmm.
but I just thought that I'd ask.
Yeah, I appreciate it. Yes.
So when you show the diagram with the proxy, I got a little bit lost. Is the actual search performed through the proxy? Because you also mentioned that Solr has a JSON API.
Mm-hmm.
So I'm just curious why React doesn't just call directly the Solr JSON API.
Yes. So the proxy.php essentially does, you send in the parameters, and then that's basically an interface between the React app and Solr. We did use that for, so I didn't write the script, but I believe one of the reasons was just to do some basic security checks. And then that also had to do that autocomplete part of it. So that's where the logic is if it's an autocomplete request where it sends it to a Drupal endpoint or it sends it to the Solr.
Yeah, so I was curious about that as well. Like if the proxy receives the churn that's being used for the autocomplete, is it making like an HTTP call to Drupal to then get the suggestions and then returning that back into React?
Yes, and that's where the search pages is used. Like it's I don't know what the URL is, but it essentially eomega.org /autocomplete search /YOG
right,
for
that's a light API, right? Like it doesn't bootstrap the whole Drupal.
It does. So when you load that page, when it hits that endpoint, Drupal bootstraps because Drupal needs to be able to return needs to bootstrap to return the response to that.
So that's a little bit slower.
Yes, yeah, it's a little bit slower.
And just following up to that, so we did a similar architecture on that hospital website I showed this morning.
Yes.
The proxy. And it came up for a couple of reasons. One is, for us, we also leveraged some caching in there against the ability to kind of use what we had already.
Yeah.
But like you said, it's you can leave the Solr server wide open and query it directly, but then you have to make decisions of like, do I want this API to be fully public, and do I want to set up my CORS restrictions there? How do I want to manage all that? Or you can just jail it and say everything goes through the proxy of this server I already have. So it's a decision, but with us, because we were also putting some caching in place, we were okay with the extra hop and the performance degradation from the extra hop, and you get that kind of performance. We did an Angular app with a similar architecture, and you get that kind of snappy response he's getting in that React app, even with the proxy in between the Solr server.
Right. The other thing I was thinking is maybe it's because of the authentication part. You don't want to keep the keys on the client side.
Right, and again, like depending on the size and scale of the project, you already have an authentication layer. You already have something in place in one place. So,
right.
For us, sometimes we start to architect and it starts to get all crazy all over the place, and then we come back a year later and we're like, where did we restrict access to that?
I really appreciate it. And in terms of anything with search, one security consideration is like, be careful what you index. Because yeah, because that is potentially accessible. So you need to keep that in mind whenever you're doing any search project, not just this kind of search project. Yes.
Well, I have several questions. Some are easier than others. I think it's quick responses. So when you said that you pass through pre-process, like the list of taxonomy terms, like in order not to make an extra request, but like, do you do the same for the initial search result? That do you pass the initial first page as from Drupal, or that is an actual query populate the first result set?
That's a good question, and I actually forget. I think the search, we're not sending the first page of requests, but we are sending this left-hand side, and I think then it's hitting the search index from there. So we're not pulling in this initial content. We are just pulling in the terms and stuff like that. So yeah, so in that pre-process, the HTML, we have a couple, call some functions that fetch the taxonomy and stuff. Because we did have it the other way. We weren't doing that originally. It was too slow.
On the Solr side, did you have to do any optimizations or any specific like tricks or tweaks on Solr itself to accommodate for anything that you came up with? Or just like default settings?
I don't remember off the so I wasn't as involved with that, so I can't speak to it. I don't think we had to do that much, but I do think we had to do some configuration changes in Solr. I think they're pretty minor. Unfortunately, I don't have the full answer, but I can find out tonight too. I'll be here tomorrow. I can answer that. Yeah, Jason?
You mentioned the Solr connector fork. How helpful was that? Does it leave the JSON API pretty raw and you're kind of coding straight to Solr, or does it give you kind of like what Solaria does? Helper functions?
Yeah, so again.
We found coding against Solr was really difficult at the beginning for developers that didn't understand it, and having a helper library gets you 80-90% is really helpful.
Yeah, that got us most of the way. All I know is we didn't really have to do that much extra development to get the communication working, which was really helpful.
Cool.
For the accessibility part, did you code all the accessibility HTML yourselves, or did you use off-the-shelf components that maybe already abstract that away from you?
So in the JSX, we wrote the HTML, at least the ones I was working on.
Okay.
We did use a couple of components that were publicly available. Yeah.
When you click on one of the results, you get these like registering parameters to track, activity. Is that did you accomplish that with Google Tag Manager, or that's something that you manually append to the URL?
I actually don't know the answer to that one either. My colleague Oksana did a lot of the analytics aspect of these things, so I actually asked her yesterday to give me a couple notes on how we're using analytics in this project. Anything else? All right, well, I really appreciate everyone here today. I appreciate the questions. It was really helpful. Thank you. I'll be here for a little bit in case anyone else wants to chat more about it.